So your first one, this was just like basically the disk. It would just be the radius, which is just the function squared. Part B then is washer, because we got a different axis there. We're at -1, so it's just the function plus 1, basically, for the outer, and the inner would then just be 1. Squared minus inner squared. Number 2, the first one is, again, just the disk, so it's just the function squared. The second one, it's the axis y equals 2. So your outer radius would be 2, and then your inner radius would be 2 minus the function. I think those are the hardest ones to set up when you have an axis in the same quadrant. So outer is a distance of 2. If you draw the line here, is a distance of 2, so it's 2 squared. And then inner would be 2 minus the function. There. Number 3, first one, we got just for the axis, so it's 2x squared minus x squared squared. Part B, it looks like we're going around 5, which is up here. What about here? 5. So it would be 5 minus x squared, that would be the outer, here to here. Outer would be 5 minus x squared, and then the inner would be 5 minus 2x. So that's what it is. Any questions over those 3 so far? Okay, and number 4. Part A, so it's just 1 over the square root of y squared for part A. For part B, we're revolving around y or x equals -1. So then the outer radius would be from here to here. So it would be the function plus 1, or 1 plus the function, either way you look at it. And then the inner would just be from -1 to 0, which is a distance of 1. So this is the inner outer. That one. And then, I guess that was it. Did you guys figure out part B? No. Okay, we'll do some more where we're going to do x values today. So today, the last 25 minutes or so, we're just going to be finishing up some of the problems from this section, and then we can start on the review on Monday. So let's start with number 5. All right, we're going to do some sketching. Set up, don't integrate, sketch the region. Just practice for that. Okay, so let's go ahead and try to sketch this first region. Bounded by 1 over x, y equals 0, x equals 1, and x equals 4. And then we got 3 different revolutions. You guys know what the function 1 over x looks like?
So going down the line, like 1 to 0.
Yeah, and then it goes sort of up to infinity here, right? It goes like that. So if you have decimals, it would be like 1 over a small decimal or a fraction, and then it sort of flips. So like if it was x was 1/2, it would flip into 2. If x is 1/3, it flips becomes 3. If x is 1/5, it becomes 5. So it goes to infinity from this way. It can't be 0, and it gets infinitely small that Okay, and we're bounded by x equals 1 and x equals 4. So at 1, it's going to be 1. So let's do that. Down to here. And then at 4, so that's the region we're talking about there. Bounded by y equals 0, x equals 1, x equals 4. And then we're supposed to draw at least one of the rectangles. I actually like to draw circles. And this book doesn't really do it, but how I've seen it in the past too is like this would do it around several axes, but if you do it around the x-axis, sort of draw this little arrow that's spinning around that. And I like even just mimic the picture there. Like that. So actually, so that's what our slices look like. So it's pretty easy setup. So first one, revolved around the x-axis. So e equals pi. Yeah, it's easy to forget the pi, so make sure you don't forget that. Easy to forget the pi, easy to forget the squares. And then the boundaries are pretty easy here because it tells us x equals 1, x equals 4. So 1 to 4. And around the x-axis is just going to be the function, right? So it would just be 1 over x squared dx. If we're to revolve around -3, put our axis down here, and then think about like our outer and our inner. Still the same setup. So what's the outer radius?
Function minus
Yeah. So minus -3 or plus 3 then. So 1 over x plus 3, quantity squared. Outer squared minus our inner squared. What's the inner?
Yeah.
It'll just be 3. The distance. It'll always be a positive because it's like a distance, right? It'll always be a positive. Minus. And then y equals 5. This one can be a little bit confusing, like what order it goes. But I like to draw it so that I can think the furthest distance. What is the outer radius?
The x-axis.
Which is 5, right? Distance is 5. From here to here, it's 5. So 5 squared minus the inner radius we get from here to here. So start with the value 5 minus the function, right? 5 minus the x squared. What's that? Okay, we'll get some x values in the next one, so maybe it'll be a little bit more challenging. All right, so go ahead and sketch that.
Which one?
Number 6. So we have our sketch there, and then this is around the y-axis. So that means we need to change this to y. So we make this x equals y squared. And then so part A, just move I, then scroll from 0 to 2, right? And just with this, if it's going to be around the axis, so we're just going to do the function y squared, squared, if we're going to go around an x value, I'm going to go 2 first. Same case to 0 to 2.
It's not controlled to. Zero,
No, the y value is 2. Yeah, the x value. Yeah, it's just a good reminder. You want it the same type of values all throughout. So if you got y to the integral, you got like y values for the index. And then if we're going to do it around x equals a negative 2, here. Now the folder goes through it. So what is how we're going to write the outer radius? Yeah, y squared plus 2, yeah. So just the function would be from here to here. And then we got an extra 2 we got to go. So that would be y squared plus 2. So, and then we got to minus our inner squared. The inner one's a bit easier, right? Just from here to here. Minus 2. Does that make sense? I guess. And then x equals 4 will be over here. So I always go from that point and then the furthest edge of it times the radius. So they're going to be the same y values. What's the outer radius for C? Let's just see, so it's 4. 4 squared minus, and the inner radius would be here. So 4 minus 3, right? So if it's in the same quadrant, it's always going to be the value minus the function. If it's in a different quadrant, it's going to be the value plus the function, or the function plus the value. This one's in the same quadrant, so it's the value minus the function. This one is in a different quadrant, so it's the function plus the value, or the value plus. But just make sure it's always positive. So like this was a -2, we had to add 2 because it's a distance. Let's see what else. We got the values. Let's do a double function one. Let's do number 9. See if that one's more challenging. And then you can use a calculator for this one. I'm going to draw a sketch. The intersection points aren't really good numbers. I always think it's good to include all of the decimals if you can. just because you're not supposed to do any rounding until the end. So I try to include all of them. And when you're writing out your intervals, you might even just want to do that where you draw an arrow and just call it A and call it B. It makes it a little easier. And then, so we're going to do around the x-axis for our first one. I'm just going to say A to B because I just wrote them out and called them A and B. And the outer function is going to be the 2 minus x squared minus root 2 to the x minus 1 squared.
Is that a different text?
Alright.
Triple check, because I tried to do that. I
Okay.
don't think I did it.
That should be 1. Right?
Yeah.
So you guys got 5.1. And then 16.3. And then second one is revolve around y equals 3. So our setup there. So the outer is going to be 3 minus the bottom function there. So 3 minus 2 would be x minus 1 squared minus 3 minus 2 squared. It's easy to make a mistake in this. It's easy to forget the pi at the end. Did you distribute the negative sign moving? I just typed it in because it was a little too many parentheses. I just typed this in as 1 plus x squared. Just to make it a little bit easier.
No, I still got to say what I have. That's not that.
What is yours?
43.0170.
Seems a little too big.
Almost one.
Just in comparison to A. Wait, did you go on?
Hold on. I got 2 points of them.
What's going on here? Like I typed
Dana, you got that one?
exactly what it. I'm so confused.
So another thing that you can do to make this maybe a little bit simpler is you can always just go to if you do vars and like y vars in that function, you can choose like y1 and y2. So when you're doing your integral math and ends, you can do, you type in your limits and then do like for the first one you can just do 3 minus, and if you want to then just hit vars, y vars function, that's y2, right? I said do y1. So 3 minus y1, close parentheses squared, minus, and just do it that way. There's a little bit less parentheses and stuff going on if you want to do it that way. Maybe it makes it less confusing. Because you don't have to write out all this. You can just use F and G. And you'll see a lot of the answers, they'll just write pi and they go from A to B. 3 minus F x squared minus 3x. And then And so if you do it that way, then you just do the Y1 and the Y2 calculator. Like, probably the
Okay,
best
doing
way
it
to
the
do it.
other way, I got that, but I don't know what happened the first like 4 times I typed it in and still got the same answer.
All right. Well, we don't have to do any homework this weekend for the weekend, so
Cool, so I got a lot of English.
start review Monday.
Preston, you also have a lot of English to do?
Or,
Yeah.
What do you guys have to do?
Most of them.